Hello, can you guys hear me? Awesome. So before we get started, all of these folks work on pretty interesting projects, and so I wanted to dive into each of them a little bit. So we can start with Chris. He's closest to me. So Chris works on Lit Protocol. It's basically a way or I'll have you give the elevator pitch, and then I'll ask some follow-up questions.
Sure, yeah. It's a decentralized access control protocol powered by threshold encryption.
Awesome. So decentralized access to what?
To basically anything. You can encrypt data, and it also supports generating signatures that you could present to a server, like a Web 2 server, in order to get some data from a Web 2 server.
And so what exactly are people, what criteria are people gating this content by?
Yeah, so we see blockchains as credential networks, essentially. So right now, people are using Lit Protocol for things like encrypting data and specifying that if a user owns a certain NFT, or if a user is in a DAO, or meets some other on-chain condition, they're able to pull down that data and decrypt it. And what's really cool about that is that that set of users that are able to decrypt it can be dynamically changing all the time.
Yeah, so that's pretty different than other kind of previous protocols, because you usually have to have this set group of people that you encrypt all the information to. So yeah, what kind of does this open up in terms of possibilities?
Yeah, it lets you do something like lock some data behind an NFT, put the NFT up for sale on OpenSea, and then disappear from the face of the earth. And then that NFT can be traded around, and everybody that buys it is able to decrypt it, and no one else is able to decrypt it. So without knowing specifically who you want to be able to decrypt it, instead you can set a condition of who should be able to decrypt it, and as long as they meet that condition, which right now is usually something on-chain, then they'll be able to decrypt it.
Cool. And you mentioned threshold scheme. What does that mean exactly?
Oh, so I love threshold cryptography. Okay, so one of the most powerful things I think that we can all agree on is public key cryptography. I mean, it underlies all of the blockchains that we use, but public key cryptography is typically not used in a way where a signer is decentralized. And with threshold cryptography, you can do all the same things you can do as an individual with public key cryptography, like sign messages or decrypt things, but in a fully decentralized way, where a network of nodes each holds a share of a private key. And they're able to decrypt things with that share or sign things with that share. The end user can collect those decryption shares or signature shares and use it to create or to recover a key or a signature that they can use for basically anything that you would normally use public key cryptography for.
Cool. And to clarify, the user who's decrypting the data, do they have access to the private key?
Yeah, that's exactly it. Technically, nobody knows the full private key. The key is generated through a process called distributed key generation, where each node in the network creates a private key share. The public key is known to the whole network, but nobody actually knows the private key. And so you have a secret private key, essentially, that can be used and worked with in a decentralized way.
Awesome. Thank you. We'll move on to Wayne. So Wayne works for Spruce ID, Spruce Systems, so feel free to give the elevator pitch.
Yeah, so at Spruce, we're trying to let users control their data across the web, and we work on a few things to make that happen. Today, we work in a world where you try to authenticate, log into a platform, and you hope that they give you access to some of your data again, and we want that to move to a model where you bring a personal data vault around from platform to platform, and you permission access to different parts of your data vault that's yours, really being able to have the same expectations in the digital world for ownership and control as you do in the physical world. When you get your passport from your bedroom, right, you don't have to ask anyone to access that again, right? You can just get it. In the digital world, why do you have to go through an intermediary to grab that? Is there a way that empowers you a bit more? So today, if you're signing in through an identity provider like Google or Facebook, if they decide to pull the rug from under you and remove access to your account, how much access are you going to lose? Is it just properties from Google, or is it everything you ever use that account to sign into, right? So we're working on sign-in with the Ethereum Foundation and ENS to figure out how to let Ethereum accounts log into websites. so that your keys can help you authenticate a session. Not your keys, not your crypto, becomes not your keys, not your identity, right? So for the people who want more control, we want to make sure there's an option for them. We're also working on a personal data vault.
And so can you describe like what the user experience would look like if they were using this sign-in with Ethereum?
Sure. So if you've ever used OpenSea and you go into your profile page and you're trying to like edit something about yourself, maybe not just anyone should be able to like edit details about your profile, like change your alias, your profile picture, right? Maybe they want to make sure it's you, right? So OpenSea already does sign in with Ethereum in their own way, and they make sure that you sign a message to create a session with you to really prove that they're talking to the key holder, right? So that way you can then edit your data and show people, your new profile picture or whatever, right? And basically that's what it looks like. In any wallet that supports signing, you get a prompt and you're signing into Ethereum, and all of a sudden when you sign it, you get a session, right? So there are a few drawbacks about the approach in the wild today that's not standardized. Basically, one of the most important things from a security perspective is something called domain binding. So when you get, OpenSea is asking you to sign into, with your Ethereum account, how do you know that message really came from the OpenSea website, right? And if you don't know, you might be the victim of a man-in-the-middle or phishing attack. So it's really important that wallets have the opportunity to ensure domain binding so that you know you're talking to the right website, right? So by standardizing it as an EIP 4361, if you go to login.xyz, you can find all the details. We did it in the open throughout community calls and everything. Then you're able to specify a pretty rigid message format where any wallet can detect this message format and be like, oh, that's the domain that I'm supposed to check, and we have to make sure that the user is on the right site. We're talking to Wallet Connect about how to do that over Wallet Connect as a protocol. We're talking to a bunch of wallets on how to check it in the browser, and that's really important. What's even more exciting is as more applications start adopting it, then wallets have an opportunity to interpret the different parts of the message and display a superior UX as a confirmation dialog. So it actually feels like you're signing in with passwordless authentication. We've seen efforts previously like WebAuthn and others, but when we look at Ethereum and related systems as the biggest PKI adoption event in history, right, then you kind of really think about, hey, most of these keys are being used to just sign mainnet transactions or on some other chain ID. What else can you do with them, right? There's a whole bunch of white space to explore there. And the first step is authentication and signing with Ethereum, and then you can go from there to a bunch of other use cases.
Awesome. And last but not least, Zach, what is Aztec?
Yeah, hi all. So Aztec is a privacy-preserving layer 2 that lives on top of Ethereum. Effectively, it allows users to conduct all of their Ethereum activity whilst protecting their identity and their anonymity by making sure that, basically all of your state that's stored on the network, instead of it all being plain text, it's all encrypted. And our specialism is performing verifiable computations on encrypted data so that folks can hide their degen NFT trading from their friends and family.
Awesome, thanks. And so Aztec is built on some cool cryptography that you've invented called Plonk. Can you describe what Plonk is at a high level? Because I know it's pretty complicated.
Yeah, I can try. So it's something that's called the ZkSnark, which is probably about as helpful a name as Plonk. But it's a very niche form of cryptography where you can take a computer program and basically construct a mathematical proof that you have correctly run this program. And the benefit to this is, A, you can encrypt the inputs and outputs of the program, which means that you could, for example, the way we use it is for private transactions, what the user is effectively doing is saying, well, here's some encrypted data that represents a trade, and if I were to decrypt it, I could prove to you that A, I own the account that's this thing is referencing, and B, I follow the rules of your blockchain, I'm not double spent, etc. I could do that, but I'm not going to do that. I'm just going to leave it in an encrypted form and serve you a mathematical proof of correctness. So I can't remember what I had a second point. I can't remember what it was. That's basically it. so Plonk was basically a way of doing this efficiently. The problem with ZkSnarks is that they've been possible in theory for years, but in practice, you'd need like monstrous computers munching through gigabytes of RAM and like churning away for minutes or tens of minutes to get this kind of thing done. And Plonk was a way of doing it, constructing these ZkSnark circuits very efficiently, so that you could actually construct these you could use these prover algorithms, say, on consumer hardware, on a laptop, in a web browser, and with much better security properties than some of the stuff that existed beforehand.
Awesome, thanks. So one question I wanted to pose to all of you is, what is an unexpected or expected technical challenge that you faced recently, or in general? Yeah, feel free to take it away, Chris.
Sure, yeah. So with threshold cryptography and with a lot of cryptography in general, it starts out as an academic idea. It starts out as a paper. And generally, there's a lot of assumptions made there, like that potentially the set of nodes that are operating with the data don't change, that the nodes are always online, that they're easy to communicate with, and there's not high latency. So a big challenge for us has been taking some of those ideas and making them work in a more practical and robust way. And really, one thing that we're very excited about is technology called proactive secret sharing. And once a number of nodes have generated a private key shares and have done a distributed key generation operation, it's very hard to change the set of those nodes. You don't want to just copy the shares over, because then more people have the shares. And if one party was able to accumulate more than the threshold number of shares, they would be able to figure out the private key, which is very bad. So proactive secret sharing lets you keep the same secret, but add and remove parties from the group of people that are able to sign or decrypt with it.
Cool. One technical challenge that we encountered trying to build these personal data vaults is allowing people to encrypt data with their key material before storing it in the data vault. That way, they minimize trust even more with whoever they're storing it with, right? And I think that's something we all like, but it's challenging because it's not standardized. And I think one of the wallets that everyone likes to support and has an RPC endpoint for it is Metamask, right? And there were some challenges, especially with Ethereum, because the SecP256K1 curve has some potential flaws when used for encryption as opposed to signing, right? So that if you want to learn more, there's a cryptographer I think some of us are familiar with, Christian Lundquist. And he had, I think several years ago, written a blog post about some brute force attacks that you could do if an attacker could pick certain points for someone else to produce. So that could be problematic or not, but this is what standardization would help with, really either tying the curve down to an area where it could perform to the quality that we want, or the MetaMask implementation actually delegates to a separate key, an ED25519 Edwards-based key, and it uses X25519 and other Bernstein algorithms to figure out how to do the cryptography for encryption, and then that's kind of like MetaMask special, right? So how do we make it more standard across all wallets so invariantly you can encrypt stuff to other people's Ethereum accounts and they can decrypt it? You can build things like messaging frameworks, you can encrypt data before you send it to someone, right? If we are looking at this as the biggest PKI adoption event, well, using our keys for encryption, is a really good use case for that. So Christian, if you're out there, I hear he's in the metaverse these days running stuff in VR. So if you're hearing this from your VR headset, please let us know how to find you so we can talk more about, standardizing this stuff. But this is something that I would invite all wallets to talk more about. How can we have standard interfaces for encryption and decryption, right? So that's one challenge and a solution that we can collaborate on.
Yeah, challenges, so many. Well, okay, so one of the things that we've been wrestling with recently is verifying Ethereum signatures inside of Aztec ZkSnark circuits, which is, right now what we do with our existing layer 2, the Aztec network, is we derive public-private keys from Ethereum signatures for users of the ASIC network. And the reason we have to do this is because the elliptic curves that we use within our ZkSnark circuits that we use to verify signatures, they're different to the standard Ethereum curve. And that's because the standard Ethereum curve, when it comes to ZkSnarks, is rubbish. Not their fault. ZkSnarks didn't exist when Ethereum, not really, we were mainstream when Ethereum turned up. But basically, the specific elliptic curve that Ethereum uses has parameters, which means that constructing a proof that you can sign an Ethereum signature within a ZkSnark is about 1 million times slower than actually doing the computation directly. But it's something that is quite important. If you want to say, use just your regular Ethereum hardware wallet on the ASIC network, it's essential. So we basically spent, I don't know, I think it's been about 2 years of research so far getting it working. But we have now. Finally, we got something practical, and we should be rolling it out in about 3-4 months. So yeah, that's what I've been dealing with.
Yeah, just to add on, I think Zach, this is the builder's dilemma in the space, right? Do you care about theoretical perfection, or do you care about building and iterating, right? And those sometimes can work together, sometimes a lot of the times they don't, and you have to work with what you got and figure out what are the requirements for your problem and take an engineering approach to figure out what's going to work. So that's a lot of the challenges. And when you're building a startup company, right, you have to figure out what's going to work for your end user. So if step one is download this random app that you never heard of and then put your most trusted key material into it, that doesn't work for a lot of people. And we have to figure out what already has trust in terms of its limits of use. So using things like wallets they're familiar with and everything else, we really have to talk to users and understand their perspective on it. And I think that's why a lot of these decisions are being made.
Yeah, totally. On that point, what is the biggest barrier for users for using each of your different projects?
The biggest barrier for users? Oh, that's a good question. I mean, in general, in the crypto space, obviously the wallet onboarding process is a little tough. You're signing up for a wallet, and it's write down these 24 words, and you're like, I'm on a bus. I don't have a pen. There's people around me. It's not a great UX. So that in general, I think is a big thing. I would love to see some more clarity around what people are signing specifically. That's a area that's pretty opaque to a lot of users, and it's hard to explain because the information is highly technical. But if there was a way to sort of humanize it in English phrasing, I think that would be really helpful. And I understand that this kind of stuff isn't necessarily a high priority right now. With respect to where we are in cryptocurrency and in cryptography, we're still kind of in the everything is held together with duct tape and chewing gum phase. But we're going to keep working on it and hopefully improve that.
Yeah. I really like your analogy to can I use this on a bus? We heard a bus factor, maybe we can introduce a bus test. And the bus test is as defined. You start off in Williamsburg and get on the B44, and you ride it all the way down Brooklyn to Sheepshead Bay. And if you can set up an account and do some transactions in that time period on a busy bus and feel confident in your result, then we have passed the bus test, right? So maybe we can add that to the literature. So some UX problems that we encounter at Spruce is that we think keys can be used for a lot of things. And if you're trying to, let's say a file storage service, maybe Dropbox, and you're trying to control all interactions with signed operations instead of creating a cookie-based session with kind of creating a stateful channel with the host, right? How would that look, right? You might have to, prompt up a Metamask dialog or whatever the signing interface is every time you want to, rename a file or, move it around, right? Or modify a file. That's terrible. You just break the user flow every time. There are some solutions to this, auto-approving signing, which has gotten a really bad rap and it's generally not a good idea. There are other approaches, but the one that we like to solve this problem, so everything can be rooted in your keys, is using something called session keys. So the idea is that what if in the user's browser or in their extension, some part of the model, you can use their local system entropy and generate a new private key. But this is a horrible environment compared to a hardware wallet or something, right? So with a horrible environment come attenuated privileges. So if we can downscope in permission what this key can actually do, make it automatically expire, right? Say that this key can access this subpath only, write a certain amount of bandwidth, that kind of stuff, and assign that delegation correctly, then that's, I think, a really exciting way to be able to operate a key inside a browser without huge friction or forcing wallets to do anything weird, right? So that's one direction that we're looking at to improving that, and especially letting the user revoke their session keys at any time, right? Today, you can't revoke all your cookies at once. So if someone stole your cookies, that you'd be done, right? But what if you could just look at all the session keys you had in existence and just decide to wipe them, and then none of those services could access it anymore, right? So I think there's some exciting improvements we can consider with things like session keys and capability-based permission models, but hand it over to Zach.
Yeah, I mean, I'm going to say something pretty similar, which is that I think one of the things that would help with user adoption and integrations with Aztec is not needing to rely on this kind of custom key derivation algorithm that we put together, because there's no standardization. So that would definitely help, because it's a huge blocker. Because you've got to, obviously, users have to trust that we've done our job correctly and that our crypto libraries are correct, but also then, because there's no standardization, it means that any integrator has to also use this custom library, and it adds a lot of inertia to adoption.
How do we start a DAO where we fund technical writers to move the curves that we like into standards organizations and go through the ringer of the ITF security group and everything else so that we can use those curves in other places, if they are indeed accepted, right? I think that would be super cool. Talk to me after if you're interested.
And my last question is, so obviously you all are very bright minds. There's also a lot to think about in all of these spaces. So like, what do you think is something that people should be thinking about more, or you wish there were more minds working on?
I mean, in 2 words, yeah.
In 2 words.
Cryptocurrency.
Standardizing standards.
Everything's public.
Awesome. Thanks.
Thanks, Anika.